Hi everyone, my name is Marc Oriol. I am from Universitat Oberta de Catalunya, and I'm going to present this talk titled Quality of Service in Asynchronous Services, an AsyncAPI extension with service level agreement support. In the context of event-driven architectures, we may have several services, in this case asynchronous services, where the service clients can subscribe to several topics or events, and these events are received as soon as they have been generated. However, these systems might encounter problems of quality of service. For instance, we might have latency problems and the events are received much later than it should be expected. Or also we could have availability problems, so the events are not received at all. These quality of service problems might impact not only the final end user of the service client for a particular service, but might also impact the whole architecture, the whole software system where we have dependencies between different asynchronous services. Therefore, we need to tackle this problem and we need to guarantee the quality of service for asynchronous services. And here I underline here asynchronous because in the field of service-oriented systems, and in particular those web services that are synchronous, there is a lot of support for quality of service in terms of service level agreements, monitoring, and so on and so forth. But there is not the same degree of support when we talk about asynchronous services. To tackle this problem, we provide here, or we propose an AsyncAPI extension with service level agreement support. In order to address it, we first need to do two steps. The first one is we need to identify what is the quality that is relevant for asynchronous services. What are the characteristics, attributes, and metrics that constitute the quality of service for this type of services? And once we got that, the second question is how we can define conditions over them in order to ensure that the whole system works as expected. Moreover, what we want is to provide these features seamlessly integrated with the AsyncAPI specification. So let's go with the first step, identify the quality. So what is quality in the field of the asynchronous services? What are these characteristics that are relevant here? Now, in order to identify the quality, first we need to understand how the quality of service can be structured. So here what we have is that the quality of service is structured in a hierarchical way in different categories. So the quality of service, we may say that is the totality of the quality characteristics of a service. And these quality characteristics, for instance, could be performance, are groups of quality attributes. So for instance, for performance, we would have things like time behavior or resource utilization. The quality attributes are features of the service that affects the quality, and they can be measured in terms of quality metrics. So for instance, if the quality attribute is, for example, this time behavior, a quality metric would be, for example, the latency of the web service. So quality metrics are the quantitative or qualitative measurements for a quality attribute. Following this hierarchical structure, there have been several proposals, and these proposals are basically quality models that instrument and characterizes the different quality characteristics, attributes, and metrics. The standard for the software systems of product quality is the ISO 25010. So here we have in this standard that the software product quality it has several characteristics such as functional suitability, performance efficiency, compatibility, and so on. And for each of these characteristics, there are several quality attributes. The problem with this model, if we want to apply it in the domain of asynchronous services, is twofold. On the one hand, it's for software systems, so it's not specific for asynchronous services. So there might be several attributes that might not be here, or the other way around. There might be here several attributes or characteristics that are relevant for a software system, but not for asynchronous services. And moreover, this quality model doesn't go deep down to the level of the quality metrics. So we have quality characteristics and attributes, but it doesn't go down to the level of metrics. To address this issue, and as part of our previous work, we conducted a systematic mapping study where we revised the scientific literature of quality models that are specific for services. And what we did is we analyzed these quality models, 47 of them, and we integrated them and mapped them into this ICO standard. So basically what we did is for each of the quality models that we identified in the literature, we integrated all of them and basically, as said, we mapped them to this standard. Here it is an example of the mapping that we conducted. So here we have the list of an excerpt of the quality models that we studied. And here for each quality model, we identified to which degree they support the different characteristics and attributes of the ICO standard. And for each of these attributes, we identify different metrics. So for instance, for the attribute of functional correctness, there might be metrics for correctness, precision, transaction integrity, and so on and so forth. And this was done in the field of quality models for services, but not specific for asynchronous services. So if we draw a Venn diagram, and yes, this is actually a Venn diagram, what we can see is that we have the quality model for software. This is the standard ICO 25010. This is the result of our systematic mapping study, where we have a quality model that is specific for services. And what we want to achieve is a quality model for asynchronous services. So what we have done in this work, we have basically looked at the quality model for services that are services of any kind, both synchronous and asynchronous, and identify those characteristics, attributes, and metrics that are relevant for the asynchronous services. Here is an excerpt of the different attributes, metrics that we have identified that are relevant in the domain of asynchronous services. So for instance, for time behavior, obviously there is no such thing as response time, because there is no response to provide in this kind of event-driven architecture, but there are several metrics in the time behavior that are relevant, like the latency, the round-trip time, if there is ACKs in the messages, the jitter, the throughput, and so on. And here we have a list of different metrics for the different quality attributes and the quality characteristics. Now that we have the list of these metrics, attributes, and characteristics that are relevant for the asynchronous services, we need to define the conditions over them. And to do so, we basically propose to use the same principles that are being used for synchronous services. So in synchronous services, there is the service level agreements, where the service level agreement, it is basically a contract between the service provider and the service consumer for the provisioning of a web service, and that specifies what are the conditions and also the quality of service that the service provider promises to their clients. And so there are several specifications, several languages to write service level agreements, but the de facto standard in terms of synchronous services is the WS agreement. And our goal is to use this same WS agreement in the field of asynchronous services, adapting the particularities that the event-driven architecture poses. So the WS agreement is basically a document that has this structure. So it has a name, it has a context. The context provides, for instance, who is the service provider, what are the services being provided, and it might also talk about, for instance, the duration of this WS agreement contract, and so on. And then we have the terms. The service terms provides the definitions of what are the particular in the field of synchronous services. These service terms could be the services, the methods of those services, the endpoints, and so on. And the guarantee terms is where we specify the conditions. In the field of asynchronous services, what we have is basically the services that provide events into particular topics and channels. So the concepts that we are familiar with in the AsyncAPI specification are the ones that relate to the service terms. And the guarantee terms are the ones that where we put the conditions that we must guarantee. Now the guarantee terms, it has several things to be included in that. So the first one is the service scope. So when you put a condition, this condition applies to a particular scope. In the field of synchronous services, the scope can be, for instance, that this condition must apply to these particular methods. In the field of asynchronous services, the service scope might, for instance, apply to particular topics, to particular channels. Or you might also state that the service scope is the whole asynchronous, what the whole asynchronous service is providing to the whole set of channels, set of topics. The second aspect is the qualifying condition. So this is some sort of a precondition that must be true in order to enforce the service level objective. So it's some sort of a precondition. It's stating that my service level objective, where I'm going to put my condition, should be true if the qualifying condition is also true. So for instance, we might specify service level objective that should only be applied during, for instance, weekdays, specific hours, or even we might also include here some conditions for some particular metrics. So for instance, if we want to enforce that the latency should be below a certain number, if, let's say, there are less than a certain amount of people subscribe to that topic, so this if would go to this qualifying condition. In the service level objective is where we put the condition that we want to assess. And finally, we might have optionally what is called the business value list. And here we basically can put rewards and penalties if when the conditions when this service level objective are not fulfilled. Now the question is, how can we integrate this WS agreement in AsyncAPI? That is the basics, the idea of our proposal. Now the thing is, in the field of how WS agreement has been defined, it is as a standalone document. So that means that, for instance, if you have a SWAP web service, which is specified in WSDL, or if you have a RESTful service specified in OpenAPI, the WS agreement is used as a standalone document. In our case, we believe that it was much more convenient to integrate WS agreement inside the AsyncAPI specification. So instead of defining a standalone document for asynchronous services, what we are doing here is integrating this WS agreement within the AsyncAPI specification. Now, how can we do that? The thing is, as part of our previous work, here you have the QR code if you're interested in the paper, we defined an AsyncAPI. So we basically extracted the AsyncAPI meta model. So here we have the UML model of the AsyncAPI specification with all the different elements of the AsyncAPI notation. And from that previous work, what we have done is we have extended this meta model with the concepts of the WS agreement. So here we can include, as you can see, the SLA with the guarantee terms, the scope that pinpoints to channels. The guarantee terms might be qualifying conditions or service level objectives, and they are basically Boolean expressions over quality of service metrics. And these quality of service metrics are the ones that we have seen, are the ones that are maps, so to speak, to the elements that we have seen in the quality model. Here we have an example of an AsyncAPI with this extension that conforms to the meta model that we have shown previously. So for instance, here what we do is in the components part of the AsyncAPI specification, we add as a component the QoS metrics. So basically here we are defining what are the metrics that we are interested to put conditions over in this AsyncAPI specification. And for instance, in this QoS metric, we can talk, for instance, for the average latency, we can put a description. And then the metric type is latency. This metric types is the list of the elements of the quality model for asynchronous services. We can include what is the unit that we want to put the conditions or measure. That could be, for instance, in millisecond. And also one relevant thing here is that we can group these metrics by event. That's something that doesn't happen for synchronous services. And the thing is that in asynchronous services, there is one event generated by the service provider, and this event is received by multiple service clients. So when we talk about latency, you might have several latencies, one for each service client receiving the message, or you can compute the average latency grouping all those messages by event. So if there are 10 subscribed clients to a particular topic for a particular event, you do the average of all these of the latencies of all these clients. And this defines basically the different metrics that we are interested in. Another important aspect that is different with respect with the WS agreement, since here we are integrating WS agreement with AsyncAPI, there is no need here to repeat again what are the channels, what are the servers, and everything that are specified in the AsyncAPI, because it's already here in the document. So here in terms of the terms, the service terms that we need to define, we only need to define the quality of service metrics. And then we go to the service level agreements, to the guarantee terms. Now in the guarantee terms, we can define, for instance, here the scope where our service level objective applied to, and here we can define our service level objective that we are referring here the average latency that we have defined here previously should be below, for instance, 300, and this 300 is, as you can see, in milliseconds. So this extension, we have developed tool support for that, and we basically had a tool that we started to develop years ago, which is the AsyncAPI toolkit. Now the AsyncAPI toolkit is an eclipse-based tool, and it provides an editor with content assist. It also checks the grammar and everything, and it has code generation capabilities. So we have basically recently in this work, what we have done is we have extended this AsyncAPI toolkit with the new meta model that includes the WS agreement integrated with AsyncAPI. So here you can easily write and specify your AsyncAPI documents with all these functionalities that are provided through these instruments of Eclipse. If you're interested in the tool, you can have a look here at the QR code. And in terms of the code generation capabilities, one of the things that we are working right now is on the generation of monitors. So in the current version, what we have is that the code generation capability of the AsyncAPI toolkit is capable of generating boilerplate code for MQTT. So basically, from the AsyncAPI specification, this AsyncAPI toolkit is capable of generating both the server-side code and the client-side code, very simple, very boilerplate code that can be extended by the obviously by the developers of the service. And what we are doing is we are extending these code generation capabilities to also generate the monitoring instruments, in the sense that when you put the conditions that you want to be enforced in your synchronous service, we are generating these also monitoring instruments that are instrumenting this boilerplate code that we are generating in order to monitor the different metrics that are here in this AsyncAPI specification. So this part is still a work in progress, but the part about the specification of AsyncAPI with service level agreement support, it is already available. So as a conclusion, we have presented here what is the quality model for asynchronous services, where we basically identify those metric attributes and characteristics that are relevant for this type of services. We have presented an AsyncAPI extension with service level agreement support based on the WS agreement standard. And we have also briefly described the tool support that we have, the AsyncAPI toolkit that provides this tool support to define these AsyncAPI documents with this service level agreement support. So that's all for that. Thank you very much. And now it's time for questions.